Hello, everyone. Welcome. My name is Rudy Leibrandt. I am a senior product manager in the RDS team, or senior manager of product managers in the RDS team. I've been with RDS for the last 2.5 years now. So I'll just kick it off and assume that a few of you haven't seen or don't know what RDS is, and then as we go along, we'll get a little bit deeper into some of the new features and functionality in the environment. So to keep things nice and simple, what RDS was designed for was to remove the undifferentiated heavy lifting associated with managing relational databases in the cloud. So we make it easy to set up and scale and operate relational databases. And these days, we support 7 different engines. Now, if you look at the logos there, you'll see 6. But if you decompose Aurora a little bit, there's a Postgres and a MySQL specific editions of the Aurora environments that we support as well. So let me kind of take you through a little bit of a journey here, right? So first is RDS is used by customers and such as yourself and users across the different spectrums of the industry. So small startups typically self-select RDS when they start building their new applications. And larger organizations use RDS for a variety of different reasons, either from initially self-managing their databases on premises, coming into the cloud, or running it for a while on EC2. And there's no real segmentation here. It's from small customers to larger kinds of environments. There's typically there's no discernible industry that we find, and there's no specific vertical that we find. It's a pretty broadly adopted solution at this point in time. The nice thing about having hundreds of thousands of customers, is that we have an amazing feedback loop. So, we come to sessions like these or conference like these at reInvent, and it's always great to hear from how different people use the solution, where they kind of struggle, and where some of the things are, right? So fundamentally, one of the things to think about is how do we take the feedback and turn that into capabilities or features that you can use every day in your environment. So I kind of built out a pyramid here, and I'll use the framework to kind of explain and to introduce some of the new things we've launched recently and take you through some of the things that we launched here at reInvent as well. So I'll start at the bottom, work my way up, and what we'll do is we'll try and get through the slides and leave about 15 minutes at the end for questions. Is that okay? So on that previous slide, did anyone see their company name on that slide? Let's see how many existing RDS users we have in the room. How many existing? Mostly new? Okay, that's kind of interesting. Cool. It is, it probably is one of those ones that is outdated the moment that I publish it. So that's probably a good place to be in. So to kind of just take you through a little bit of a history lesson, I won't spend too much time on this, is we introduced RDS in 2009. And you can kind of look through the kind of key things is we released Multi-AZ, which we'll discuss a little bit today, in 2010. And you can see that there's a fairly significant pace of innovation through the technology. So from initially just using RDS from MySQL to adding new engines in Postgres to getting into Aurora, and then as we go along, you can kind of see that the feature velocity increases over time. So that's kind of there's not really anything I specifically want to highlight. I think we can spend the time here discussing how we do these kinds of things. So I'm going to drill into the choice layer first here. So typically when we think about choices, as we know that most there isn't a situation where every kind of implementation, every architecture, every application looks the same. So typically when we speak to customers and we ask for feedback, is one of the primary things we hear from them is that they need choice. We need choice in deployment options, we need choice in pricing options, we need choice in location strategies. So there's a number of things that we can take through, that we're going to talk through here. So first, I'm just going to focus on the new regions. Then I'm going to drill into the new instance types. I'm going to drill into some of the capabilities we enable in the databases, and then talk about deployment flexibility. So last year we introduced 3 new regions. One in South Africa, so that's the accent. I'm originally from South Africa. One in Italy, and another one in Japan. Next year, you can see that we plan a number of additional regions there, and you can see the locations in there. And from an RDS perspective, that's kind of important. Is when I initially joined AWS, what you see here is generally what I see as one of the reasons that customers choose AWS and RDS is the ability to actually take the application and the data and put it as close to the customers that you want. So there's a few ones there. Last year added support for a few local zones. The local zone in Los Angeles is one of the things that we support there, and with plans to support it to extend that out to further local zones. So instance types are interesting. Is with RDS, historically, we've been pretty conservative about supporting new instance types. And the reason for that is we're a managed service, and we want to be very opinionated about the kinds of things that we support. We want to eliminate choice in some cases to make it easier for customers to operate. But the one thing that we found is that with the Graviton instances as an example, is we saw an opportunity to provide better price performance in some of the workloads that we saw, right? So what last year in 2020, we introduced the first Graviton instance types, the M types and the R types, into the fleet. So they were kind of matches with the Intel instances that we had. This year, we introduced two more options. We introduced T4G, or the burstable T instances, which are great for development and testing and smaller workloads, a little bit burstable. And that was kind of that matches kind of the profile that we have. With RDS, we've always had T's, M's, and R's. Later in the year, we introduced X2G instances. So X2G instances have up to have a larger memory footprint here. We can see that those are optimized for read-heavy workloads, and they come at a pretty significant price discount to what you see on the Intel kinds of environments. We also added a new instance type for SQL Server, and this was the first time that we started thinking about RDS and using local instances or local storage as part of the instance. If you've been familiar with the technology, RDS uses EBS-backed volumes to store data durably. And there's an advantage to doing that is there's an excessive amount of nines from an availability perspective with that. And from a durability perspective, building the solution on EBS makes it simple for us to actually scale storage and take advantage and grow with those technologies. What we could do with the local instances is start taking advantages of some of the capabilities natively built into the database engine. So with SQL Server, one of the performance recommendations you typically get is to separate out the transaction log and the storage and the data stores. And the reason you would do that is that typically it improves write performance. So you basically, the performance requirements for the transaction log and for the storage is generally different. One is a serial write and the other one is kind of more randomized. But in the past, we kind of avoided doing this because it could increase operational load, right? So now you have to kind of care about managing storage in two different places. But we decided eventually that the trade-off here from a performance perspective is significant enough for us to introduce that the complexifier there, if I could call it that. And then finally, more on instances. One of the things we did here is introduce new memory-optimized instances for RDS and Oracle. And that has two benefits. One is obviously performance. Another one is that it's more efficient with the license pool. So if you run RDS Oracle and bring your own license mode, this provides a way for you to make sure that you can run in inside of the license quota that you set up for the environment. So, I mean, the thing to think through here is in the past, RDS, we were pretty conservative with instance types. We are proactively looking at new kinds of instance types for us to certify with instances. So if you had any requirements or any feedback on instances that you would like to see us support, you walk up over after. I mean, some of the things that we're considering and working through now is we've started seeing more and more database workloads, for example, running on C types. That we've, on the Oracle and SQL Server side is we support instances with higher clock speeds. And later on in the presentation, I'll discuss some other instance types with local storage that we're starting to use more generically in RDS as well. So this is an area for us that's an important thing, and we want to evolve our thinking from the way that we had it set up previously. So the second category, and there's lots of text on the slide here, and I'll just take you through the important things, is when we look at the way that we innovate, is there's kind of there's different dimensions of how we think about innovation in RDS. And the one element is you can think about our control plane or the features that we enable for RDS. And another way to look at our managed service is that it's essentially hundreds of workflows that we've built and curated and optimized over time. And what these workflows do is they ensure that there aren't hands on keyboards on your side and on our side, right? To make sure that the operational burden of managing databases stay low. The second dimension for us so the second dimension we can innovate would be on the core AWS principle stuff. So for example, supporting new instance types, looking through new storage types, and improving the way that we adopt AWS technology. Another way for us to innovate is to enable certain capabilities inside of the databases that we might not be supporting right now. So as an example of that is, major versions are important. We have goals to release major versions almost as quickly as we can after a database vendor releases them. For example, Postgres 13 was recently released, and we have a few things that goes into that is we kind of plan and make sure that we don't ship a release like a .0 release into production and get into a situation where there's lots of bugs with those things. So after we validate them, we release those minor versions or some other things. But here's some additional features that we kind of worked on this year. One of the things that I thought was interesting is we started getting more and more requirements from customers to store and find a way to store time series data in Postgres. And one of the extensions that customers were asking us to enable was something called time stream. And time stream is a very popular environment that gets used for time series analysis for observability. But when we kind of sat down and spoke to the Postgres community, we asked customers about questions. Two extensions came up a lot, PG Parkman and PG Cron, which are two extensions, open source extensions available under the Postgres license that do a really nice job of providing time series capability. So we enabled these functions, and we found that they could support almost 80% of the use cases that time stream could do. So we enabled those extensions, and again, we only get to think about those kind of things if we hear them from customer kinds of environments. We then took, on the Postgres side, also took some of the capabilities we previously designed for Oracle. So cross-region automated snapshot restores for disaster recovery environment. I've got a slide a little bit later to explain how that works. So that's another feature where we had a requirement from our Oracle install base to deliver the functionality first. Didn't really have much signal from the Postgres community, built it out. And once Postgres customers started seeing that, asked us to deliver that in Postgres as well. So we went ahead and did that. Going down a little bit further, enhancements such as the replication filtering in MySQL is another kind of an example of functionality that our engineering team or our service team can take care of. Is here what replication filtering allows you to do is to replicate a subset of data to a downstream system, so you don't have to copy all of the data or snapshot or synchronize all of the data from one MySQL system to another. Now, in the past, we didn't support this because of, again, of the complexity of operating this and some of the risks that you might take from a durability perspective. But over time, as our solution matures, we could go and implement that. On the SQL Server side, the extended events is a protocol or a functionality built into SQL Server. We didn't support that previously. This year, we added support for that after extending some of the core SQL Server functionality around integration and analytics in previous years. So here, kind of, you can see the theme here. Thematically, what we're looking at is what are the kinds of functionality we don't support in the database yet, right? Which ones can we enable out of the box? For example, there's no security risk, there's no operational risk, and there's no risk to, from a deployment pattern perspective on those kinds of environments. And that kind of helps us implement those different things. So the last thing we want to introduce is a new feature or new service deployment type that we launched a few weeks ago for Oracle and launched it today for SQL Server. So this again is on the spectrum of choice, and kind of the situation that we uncovered here was quite often we would sit with architects and with developers, and what they would tell us is that they love RDS, but they've got a set of use cases where RDS isn't fit for purpose. And an example of this would be that they run packaged, or like let's say, for example, Oracle EBS, and they cannot run the managed service because you need to install things on the RDS environment. And with the managed service is we make sure that that's pretty secure and that no one can touch the operating system or the host or install anything. So with RDS Custom is we change that model a little bit to give you most of the choice and flexibility you see in EC2, but we still have the ability to provide the magic that RDS does to reduce the operations and do the automation for you. So one of the ways we do this, a new concept we introduced, is something we call the support perimeter. Now, what a support perimeter allows us to do is to basically set up a set of rules in the configuration that allows us to say, well, if these things stay intact, we can provide you with the automation on the RDS side. So that support perimeter concept allows us then to kind of say that, okay, you can install agents, like monitoring agents, you can install applications, you can do what you need with the environment, you can create, you can run the kinds of versions that you want. If RDS in the managed service, for example, doesn't support a very specific minor version, or let's say, for example, you've got us into a situation with SQL Server or Oracle where there's a one-off patch specifically for your environment. Those kinds of use cases we would have to exclude out of RDS support previously. We can address all of those with custom. Another really important use case for us, specifically on the Oracle side with custom, was providing more advanced availability solutions. So as an example is how would you set up active-active scenarios with Oracle on the RDS side, right? Is the model that we have is what we call cheap and cheerful, right? So we have a multi-AZ offering. It provides really good durability, really good availability, and solves 90% of customers' problems. But if you're in the financial services industry and there's a front-end trading application running on that environment, sometimes you have to set up 8-way replication to make that set of capabilities work. So with this model, you can go and install Golden Gate or Data Guard on the same environment and set those things up. So, a way to look at custom is our first kind of jump into a more semi-managed RDS environment. Just to go back one. The one thing that is important is if someone asked me, okay, Rudy, I'm coming in from on-premises, I run Oracle, our recommendation is going to be to start on which your right-hand side there, and start with RDS, right? So the idea would be is that we are always going to recommend RDS because we can provide the appropriate operational support. We always think there are going to be a little few more rough edges or a few sharper edges around the custom environment, but it is absolutely an environment that we think customers are going to need to run. So these are some of the use cases. I mentioned a few of them already, like custom and packaged business applications, situations where you need really granular control, lift and shift. So I run a very specific environment in on-premises or in EC2, and I want to bring that in. And then disaster recovery. We've got certain situations where we've got customers running Oracle systems on premises. They're not really ready to bring that specific workload into the cloud, so that we can provide a DR environment that looks and feels the same as the on-premises environment does, without kind of requiring. And the challenge is, right, is we've had some customers run their disaster recovery environment in regular RDS, but if you do a switchover, you want these environments to be identical, so it doesn't help you to have them slightly off. Okay, so I'm going to jump around. So that was on RDS, and kind of the way that I've got this presentation structured is that I'll cover some RDS content, and then I'll jump into some of the Aurora things for a little bit. So similarly with Aurora is there's a number of capabilities here. I think the more important ones here I'll jump straight into is the first thing that we did is we increased the storage space. So before this year, you could only get up to a 64 terabit Aurora environment. We introduced first time an ability to stream audit data and data access information to a different environment. And we introduced integration with AWS backups this year. So with AWS backups, you can configure backup policies and retention policies for snapshots and for backups. And what's great about that is it includes all of your AWS assets. It's not just for databases. When I drop in a little bit to the Postgres environment, and the way that we've been designing the Aurora system is to kind of be in a position, be in a position for us to adopt the new major versions of these environments really quickly. So if you've been in and around Aurora for a while, we've been really good at doing this with the Postgres environment, but we did fall behind a little bit on the MySQL side. So this year, we've refactored the things that we need to do. We added support for MySQL 8, and we're in a position right now where we can adopt, from a lifecycle perspective, can adopt those versions really, really quickly and effectively. So those are some of the larger things in the environment. You can see some of the other things, which is kind of interesting, is on the Postgres side, specifically on the Aurora Postgres side, a lot of the functionality that we talked about with RDS, with time series data and those kind of things, they become available through extensions in the Postgres environment as well. So staying with Aurora a little bit, last year at reInvent, we launched a private preview for a project we just called Babelfish. So let me talk through the genesis of the project. In AWS, as we've been pretty successful at helping customers migrate database workloads from Oracle and SQL Server and proprietary and commercial databases to Aurora. But there's always a set of applications that are extremely difficult to port and to migrate, because fundamentally is most of the migrations from a heterogeneous database requires you to make application changes. And even if those are small changes, often the risk that you take is that the application developers don't have the time or don't have the inclination or the motivation to go and change those applications. So you can copy data from one structure to another, but the applications are generally the sticking point. So what we were looking for were solutions to the problem that, well, what can we do to make sure that customers wouldn't have to change their applications? So to keep it nice and simple is what we did with Babelfish is we developed capability inside of Postgres to allow it to behave like a SQL Server database. And what I mean with that is we built a new procedural language into the Postgres environment that is like T-SQL, the Microsoft SQL Server dialect, and added support for the TDS wire protocol directly in Postgres. So, so the outcome of that is that a customer that has an application designed and built for SQL Server could take that same application and point it directly at Aurora Postgres without making any application changes. Now, the caveats is that we targeted the most common SQL Server functionality, so this won't be a silver bullet for every application. But during our preview, we previewed with almost 100 ISVs and customers and that did these applications. And the feedback from most of them is that for a large portion of their applications, this just works. Is the applications, whether they're .NET Entity Framework applications or those kind of things, they would just port pretty easily. Now, the thing that was interesting about the way that we released this is when we launched it, we said that the project would be open source. And today you can go to GitHub, you can get to the Babelfish project, you can download it, and you can deploy this into any Postgres environment, an on-premises one, or one of your own Postgres environments. And the idea here is to help foster kind of community adoption and to get the community to help us with situations where you will have developed or have implemented some very specific corner case of the SQL surface area that we don't support. So that's the Babelfish project. Okay, so that's the section for choice. So all about choice, which databases do I want to run, where do I want to run them, which kind of instances do I want to run them on, which kind of architectures do we support. The next category here is security and compliance. So to jump into that is the first two things here, just to kind of cover off auditing is we introduced database activity streams a while ago, only support for Aurora. What the technology allows you to do is to take activity streams or the access logs of your databases and stream them down to third-party environments. So you can applications that manages database access for compliance reasons. And let's say, for example, you needed to know which of your employees accessed which parts of data at which time to kind of understand unauthorized access and potentially exfiltration and those kind of things. So we released this for Aurora in 2019 and expanded support for SQL Server and Oracle in the last year, and kind of looking at when we'll be supporting the open source databases next. I really like the next one, and that's because I'm partial to some of the open source things, is we ran into a situation where there was this plugin that most customers were using in MySQL 5.7 to audit activity streams on the open source side, on the MySQL side. And what happened is that plugin was provided by MariaDB. It was one of the MariaDB plugins which customers would then take and they would plug it into MySQL, and this would allow them to efficiently audit transactions and typically use this to manage the DBAs, right? Make sure that authorized access and those kind of things were all above board. But what happened is that MariaDB stopped enhancing the plugin for 8 support. So what we did is we updated that plugin. We contributed the changes back to the open source community. And for most of our customers in financial services using RDS MySQL 8, that was a good one. Then compliance enhancements. These days, there are n number of compliance regimes we typically have to provide controls for. So one of the things that we had to do is to provide support for TLS versions and ciphers, and provide a little bit more control for customers to choose what they want to do here. So we can now enable, for SQL Server, can enable and disable ciphers and specific versions of the environments. And you can see lower down on the list is we're providing the same kind of support in RDS, Postgres, and Oracle. And then, we had a requirement in financial services to adopt SCRAM support or SCRAM authentication in RDS Postgres. So these are things that we always look at we monitor the regulatory requirements. We spend time with people in those industries and make sure that we provide the most appropriate controls for that. Another requirement was for improved application security. 2 years ago at reInvent, we introduced a technology called RDS Proxy. And Proxy is good for 2 things. It's good for building software as a service-based applications where you want to manage the connectivity to the database environment. So every connection, if you've been around databases, every connection you make to the database is an expensive operation, takes up memory, resources, wastes CPU, and all of those kind of things. So with Proxy, we can multiplex those solutions. And what we started doing with that model is once we had customers using the Proxy, we started looking at enhancements that we could make to make security a little bit easier. And one example we have is how we deal with secrets. So we integrated Proxy with Secrets Manager. So what we can do there is allow applications to use IAM authentication to authenticate to the proxy. The proxy is then able to look up and map the KMS key, and then allows you to establish the connection. So the question is, well, awesome, why would you do that? Is, well, if you didn't do that, you would have to go and embed your connection strings and usernames and passwords in every single microservice that you decide to connect to the environment, or every Lambda that you build. So this allows you to kind of centralize your password management a little bit smartly. So this is one of the things. It's another kind of the surface area of the application that we're starting to get into and involve anymore. Proxy has a number of other use cases. For example, one of them could be to reduce the time that failovers take from one database to another, or to kind of make it simpler for your applications to split read and write workloads and those kind of things. So that's kind of the solution here. But Proxy, there's a bunch of things that we can do on the proxy side to affect any of those dimensions, whether it's choice and security and availability and durability. So durability and availability. So the first thing is, anyone experienced with Aurora Global Databases? Has anyone used that? Okay, a few in the room. So Aurora Global Databases is a feature, a set of features that allow us to make sure that there are redundant copies in different AWS regions for Aurora databases. So it allows us to kind of not only distribute the data globally, but it also allows us to do a number of things with organizations that need their data closer to certain regions. So this year, there are a few interesting additions to global databases. So early in the year, we launched a feature called Managed Planned Failover, which is something that we were working on for quite a while. And this comes into play quite a lot in compliance environments. So we have customers specifically in financial services that have a requirement to every now and then flip the primary and secondary locations for their databases over. So they need to flip from one region to the other fairly frequently to prove that they can actually fail over to their DR site. And before we did this, you had to do this fairly manually. It was really, really difficult to do. So these days, you can quickly flip that over with managed failover. The second one on clone support is Aurora supports this ability to create a thin clone. So what a thin clone allows you to do is you can quickly create a clone of a database without copying all the data. And as we start using it, it fills in the correct database pages. But we didn't support that with global databases. So this is a parity feature, it's a catch-up feature, but important for us to go and do. I'm excited about CloudFormation and Terraform support. I mean, it's, if I'm self-critical, one of the things that RDS hasn't done well historically is be proactive about CloudFormation support. And CloudFormation seems to be more and more important for customers, and so is third-party support for things like Terraform. So we're happy to kind of, that we're starting to see more capabilities on the Terraform side here. Then at the bottom there is a feature that we got asked for by customers that started using global databases. And an example we had here was in video conferencing where, customers, we have this global database concept. Let's say, for example, we've got a part of your cluster in the US East and another one, but perhaps in Japan. What customers were struggling with was finding a way to do writes, because fundamentally you have to pick one writer in an Aurora cluster. So what the new functionality allows us to do is when you issue a write to something that's a reader node, it will automatically forward that to the correct writer. Okay, so this is new. So if you remember, I don't know if you remember the history slide. We initially announced support for multi-AZ instances or multi-AZ instances for RDS in 2010. So this is the first major enhancement that we've made to multi-AZ since that time. So we're happy to introduce, and this went in preview last week, into public preview in 3 regions, to announce Amazon RDS Multi-AZ with readable standby support, okay? It's a mouthful. My marketing team really didn't help with this one. We could have been more catchy. So fundamentally, if you think about how multi-AZ works today, or how multi-AZ deployment option 1 works, is that we make use of synchronous disk copy, synchronous disk block replication with EBS to set up a standby instance. And what that allows you to do is to get some durability guarantee, right? So we can eliminate data loss through that kind of a model. The downside is you can never use the second environment unless you fail over to it. So it's kind of a cold or a passive standby, if you would call it that. The other downside is, synchronous block replication is what, if anything? You think, is it fast? Any idea here? It's slower, right? It introduces latency. So if I have to write once, I basically have to write to a secondary instance. And the difficulty with that is that the transaction doesn't commit until you've hit the write on the second environment. So if we, for whatever reason, run into a situation where there's a disk failure on the secondary instance, right, which, EBS is awesome at. It's like magic. It's disk disappears. No one has to run around and figure out what's going on. It just replaces the disk. But your application developers hate that because all they see is a big latency blip on the application, right? So they get frustrated with that. So not many ways to solve that, right? Is we can write faster. There's not many not many optimizations we can do to that model. So with readable standby support is the way that we've changed the architecture is we use different instance types in 3 RDS instances. So we add local storage to the instance, and almost like the trick we were doing with SQL Server, is we store the transaction logs on a local storage, on NVMe storage. And then what we do is the moment that we write into the transaction log, we write to 3 logs at the same time. We use a quorum, 2 out of 3 commits, and then we say the transaction is committed. So first thing that does, it reduces the write latency. We take you out of the commit path. So, so jitter and noise from your EBS solution gets eliminated through that. The second benefit is that those standbys are now readable. So readable standbys give you 2 things. So now you've got a way to scale read workloads, which is kind of obvious. And the way that we've implemented this thing is in a cluster construct. So if you log into the RDS console, it'll give you a writer endpoint and a reader endpoint. So you can point your application to the writers and readers. And then the other thing that readable standby allows me to do is to fail over faster, right? So if you think about the previous model, I've got a cold standby, I replicate disk blocks, something happens to the primary, and I fail over to the secondary, is I have to start that database up, I have to go through a recovery process, and then that environment goes up. If the databases are already up, that failover time can be minimized significantly. So, to give you a perspective, we think in normal circumstances, a failover in mode 1 takes about 1 to 2 minutes. This could take about 20 seconds. So that'll give you an idea. And most of the time is going to be spent in DNS. But the database is up and running. So not for SQL Server yet. Well, it's one of the things. I mean, typically when we release features and functionality like this, is we want to see it work for a set of engines before we move it to the other one. So once this gets out of preview and in GA, and which we hope is somewhere in Q1, we'll start looking at other database types. Okay, we talked about this a little bit earlier, is in the past, if you wanted to set up a disaster recovery environment in a second region and you wanted to do it with snapshots and not a real-time replica, you could always take a snapshot and you could copy it to a different region. So what we've done is built some automation to do that for you. And we've done that with RDS Oracle, RDS SQL Server, RDS Postgres. So the new environments will be coming up next. But I'm just animating to give you a sense here. So what this does, it basically takes care of all the scripts and the workflows that you typically do when you have to deal with snapshots and copying them between different regions. So it could do a point-in-time restore of your database in a different region using this capability. Okay. So then, this is kind of what, if you had procurement people in the room, this is the area that they generally are interested in, is what do we do on the price performance side? So last year at reInvent, we introduced a new model for Aurora, Amazon Aurora Serverless v2. So, with the Serverless v1, provided this ability for you to basically go and design and build your applications and not care about the instances underneath the application. So you didn't have to take care of thinking about how it would scale an instance. The technology would take a look at the workload that you're throwing at it, and it would scale up automatically. What customers didn't like about V1 is we scaled in pretty large increments. So we would scale, let's say, from 2 vCPUs to 4 to 8 to 12, so that kind of a model. So it had big jumps and then would back off slowly. With and the other thing that customers didn't like with the model is that we built it in a way that we couldn't support certain Aurora features and functionalities such as global databases or read replicas. We didn't have a service level agreement for it. So V2 was a reaction to what we saw from customers here. So with a new model, the scale is instant, so we scale in tiny increments, like a quarter of a CPU kind of environment, which means as your application ramps through performance tiers, Aurora Serverless will scale with you, and as the workload disappears, it'll back off a little bit slower still to make sure that we don't cause too much pain to the caches here. The older solution behind the scenes had a warm pool. So we had, if you can imagine, a bunch of EC2 instances. And what we would do is if you had to scale beyond the boundary of a machine, in the background, we'd have to swap instances. The new technology doesn't use that. It uses a new specific EC2 instance type that allows us to scale through those boundaries. So we don't have to move you from one machine to the other. That means that scaling is instantaneous. It doesn't take time. You don't see, on the server, the original model, we could see latency blips for the application. Your application wouldn't crash, but it would just hang. We don't see that with this technology. And then obviously the other ones are, we would support an SLA on this, and we could support all of the other Aurora features on this. The other nice thing about this model is you can flip between provisioned and serverless mode. So you could start off a new application development environment on serverless. You can run your development and testing. You can go into production. You can monitor it, and if you see that your usage is fairly stable, you can flip it to provisioned, get an RI, and make sure that you optimize the cost for that. And then finally, Graviton. We talked about Graviton a little bit earlier. Is what we've seen with Graviton processors are actually pretty interesting. Is at best case, what customers tell us is that, hey, this runs better, so they get a performance increase at a price decrease with the solution. At worst, what customers are telling us, it runs the same. It meets their performance requirements from their old M5, R5 kind of environments at a lower price point. So that's kind of, so what you can see here are just two benchmarks on the M types where you can see a little bit of how this technology performs. Okay. So the last one is ease of use. It's interesting on the ease of use side is there's two things that we want to have ease of use for is we typically model and design and build for two personas, right? And the one persona is a little bit of an aggregate. An operator, so someone like a DBA or an IT or a DevOps personnel. And the other persona that we model is the developer one. So making sure that RDS is easy to use for someone who's developing their first-time application. So those are kind of two of the things that we can do here. So let's go through them a little bit piece by piece here. Did anyone see this announcement on DevOps Guru for RDS today? Okay, so let me talk through it quickly here. Is DevOps Guru, again, just thinking about the why here, is in RDS, we've had solutions that help customers diagnose database load and performance for quite a while. In the RDS console, there's this capability called enhanced monitoring. And there you can look at metrics, you can look at CPU, memory, and those kinds of metrics. We then enhanced that capability a few years back and introduced a platform called Performance Insights. And what Performance Insights allowed you to do is to kind of monitor real time and see what's happening on the database load side, but also retain the load data for analytics. And we would feed that into things like CloudWatch and those kinds of things. So DevOps Guru is a machine learning powered advisor that uses Performance Insights data to help you identify what specifically is going on with your database when it hits those performance steps. So what it does, it uses anomaly detection models based on your data. So it understands that something is going on that shouldn't be going on based on your data. And the way that it does that is it uses the performance insights information that you enable and store to make some of those decisions. So the way that this works is if you have DevOps Guru or you enable DevOps Guru and you enable Performance Insights, then you get the functionality included as part of that. So this is kind of a step one for us. I mean, if we think through the evolution of where we would want to see relational databases, is at some point it's hands off, this thing takes care of itself. What this does here is it provides advice and action for you to take when it notices certain things. So some of the things we think we can build out of this over time is, so this here takes care of the IT operator or the DevOps model. One of the things that we're working through is what can we do on the security side? So can we, for example, take some of the same data and insights, feed it into guard duty, and start kind of informing customers of anomalous data access environments, so data exfiltration and those kind of things we're looking at from a next perspective. So we're really excited about this capability. It's kind of a foundation for a lot of things that we can do to optimize database workloads even more. Oh, and important is DevOps Guru today will support the Aurora database instances first. We'll add support for the other databases after that. So we talked about proxy a little bit earlier and what it does, and just to kind of a refresher is the proxy has proven to be really, really useful when people build serverless applications and Lambda-based applications. And kind of the key use case there is to deal with database connection management. Now, if you're a Postgres customer, you know all about database connection management. Is once you hit a certain connection limit, that application comes to a crashing halt. So anything you can do to manage that for applications is generally pretty helpful. But you know, some of the other properties of the solution is it allows us to provide better availability for applications and make things fairly transparent, right? So the application connects to proxy, and under the hood, we can do a bunch of different things here. So this year, we added support for Aurora read replicas. We enabled cross-VPC connectivity. So this is something that customers asked for a lot, is where, you know, Lambda functions and those kind of things running in different environments. With shared VPC support is we allowed, we had this solution where you almost had to create a VPC for every kind of database environment. So this allows you to kind of reduce the cost and the operational load there a bit. And then one of the things we did then is added support for one of the open source engines as well. So initially, again, just to kind of give you a sense of how we typically do these things, is we find a scenario. We initially only release proxy for Aurora instances, and we've added support for the open source engines after that. So then one of the other things here on the ease of use side is this year we open sourced our own database, a set of database drivers for RDS and Aurora databases. So these are drop-in replacements that are available on GitHub for the MySQL and Postgres drivers. And the reason we did that is that we found that in some scenarios, the drivers provided by the open source communities aren't really aware of concepts like writers and readers and those kind of things. And you had to do quite a lot of work in your application to understand how to fail over with them. So these solutions are RDS and Aurora aware, but they work as well on open source MySQL or self-managed MySQL and Postgres deployments. So we started the project. I think we went into like a private beta last year around this time, and open sourced the technology a while ago. So that's just another example. And you can see there, it's aware of the topology of the Aurora or the RDS cluster. It understands what a read replica and a writer is. And if there's a failover scenario, it understands where the failover options are, and takes it from there. OK, so kind of just to summarize that, right? So if I went back a few things, just to kind of give you a sense of the pyramid here is choice is kind of the foundational thing. When we speak to customers about how you want to deploy applications and databases, is, you know, we've started moving away from a model where we are pretty rigid with options. Is we will run these instance types and those specific kinds of environments, and we started opening that up a little bit. We keep on in security for us is job number one. So if the service isn't secure, no one uses it. So, you know, we keep investing in those kinds of environments. Durability and availability introduced now with, you know, for the first time in 11, 12 years, introduced a new model for multi-AZ, which we think is going to be awesome for people that need more performance, more write performance out of their RDS systems and need that read scale. On the price performance side, the thing to think about there is DevOps Guru, the ability to use an ML advisor for the environment. On price performance, what I'd look for going forward are more instance types. And again, I invite you to tell us and my team about the kinds of instance types you want to see supporting RDS. And then finally, ease of use for us is all about the ease of use for developers, the ease of use for operators, and the ability for someone brand new to RDS to use it successfully for the first time. And to wrap up, I wanted to invite you, and if you wanted to take a photo of that, those are a bunch of other sessions that you can attend here at reInvent that kind of goes into a number of different environments. So, you know, at the bottom there, you can see there's a breakout session for the new Aurora Serverless v2. I'm pretty sure that if you scan the catalog, you'll find Swami's DevOps Guru kind of session, and there will be some sessions around there. The Babelfish session, if you're interested in migrating applications from SQL Server to Aurora or to RDS, that's a really good session to go and attend. And then yes, there's a number of the other one that I think is kind of interesting is if you're a startup and you're starting out with RDS. We have a chalk talk that we designed for customers who are building their very first application and how they should build that application to not run into scalability limits later on, which is kind of it's kind of interesting is what we see with startups is, it's like I said, they self-select, they get to a place where they say, I'm going to build a new application on AWS, I need a database, I'm going to use RDS, right? Makes sense. Just a 2-3 man startup team, doesn't have a DBA. And typically, we don't hear of these customers for a while until they hit product market fit, and they suddenly have thousands of customers, and they've designed their models with a pretty rigid relational schema, right? And that session is all about how to build your applications so that you don't run into those scaling limits a little bit later. So if you, I'll put my pitch in or my punt in for that one. Okay, so we have about 9 minutes left, and I want to open it up for questions. Oh, question over here.
So for EC2, they move from going from reserved instances to say that's been really helpful for us. And I was wondering if you had kind of the same thing. So that would really simplify it.
Okay, so the question here was within EC2, we introduced a concept called savings plans last year, and the question was whether RDS is planning to adopt that. It's one of the most often requested features in our backlog is supporting savings plans, and what we are working on a plan there. We don't know if it will be exactly savings plans, but we know we need to solve the complexity around RI management for customers. So today, it's pretty complicated. You have to know exactly which instance, which region, and which capacity you want. So we're working through a few options with that. It might not look exactly like savings plans, but that's kind of at the top of our priority list and something we want to solve. More questions? Okay. If there are no more questions, I'm going to hang around and, oh, there's another question. Yep.
Any idea on when Serverless V2 will be released?
You know, we hoped that we would be ready by this time. But we're running a little bit late on a few capabilities that we want to add and make sure that it's in the program. So I wouldn't think that it would take much longer for us to GA that. Anything else? Okay, so with that, then thank you for attending. I'll close the session and I'll hang around outside. Thank you.